1.5 is parametric relations, which is something new for my Algebra 2 students, because I don't think that's, I don't think we've talked about parametric relations. I think that comes up more in pre-calc and calc. And then inverses, which you've definitely talked about inverses some. We're going to keep talking about inverses, so those aren't brand new. To get us started, a little bit of vocab. Relations defined implicitly. So relations can be defined explicitly or implicitly. I'll give you a hint. Explicitly are the ones we like. Explicitly are the equations or functions that are already y equals, right? So it's real easy to plug an x value in. Relations defined implicitly, where the relation, so equation, function, is not specifically solved for in terms of y. And usually the implicit relations are ones that they're not easy to solve and make y equals. Okay, so not specifically solved for in terms of y is the key of what it means to be an implicit relation. So, for example, an example of an implicit relation, this example in 1, x squared y plus y squared equals 5. That's a good example of an implicit relation because it's not solved for y, and I hate to be the bearer of bad news, but it would not be easy to solve for y. Okay, it would be definitely a lot more complicated. Now, that doesn't make this problem specifically difficult, or, could be easier, but it's not impossible. Determine which of these ordered pairs, there's 3 of them given, are in the relation defined by x squared y plus y squared equals 5. And then we'll come back to is the relation a function here in a moment. So how do we determine which of those ordered pairs are in the relation? Plug them in, yes? It'd be easier if it was y equals to plug them in, but it's not. So we're just going to go with it. So we're going to be plugging them into x squared y plus y squared equals 5. The first one I'm going to use to plug in is 2 negative 5. You guys are pre-calc level. Every place we see an x, we put in a 2. Every place we see a y, we put in a negative 5. So 2 squared times negative 5 plus negative 5 squared. And the question is going to be, does it equal 5? So what do we end up with here? 2 squared times negative 5 is going to be negative 20 plus negative 5 squared, 25. What do we know about negative 20 plus 25? It's 5. So what do we know about the ordered pair 2, negative 5? We don't know it's a function.
We know it is.
We know it's in the relation. Okay, we know this ordered pair works for this equation that may or may not be a function. We haven't got to that. Okay, next one. 1, 3. So again, we're using the equation x squared y plus y squared equals 5. This time plugging in 1, 3. 1 squared times 3 plus 3 squared. And the question in the end will be, does it equal 5? 1 squared times 3 is going to be 3 plus 3 squared, which is 9. What do we know about 3 plus 9? Okay, it does not equal 5, right? So is the ordered pair 1, 3 in the relation? No. And we can try the same with 2, 1. X squared y plus y squared equals 5. This time I'm using 2, 1. 2 squared times 1 plus 1 squared equaling 5. Let's see, what do we have here? 2 squared is 4 times 1 is 4. 1 squared is 1. What do we know about 4 plus 1? It equals 5. So what do we know about the ordered pair? 2, 1? It's in the relation, yes?
Yeah.
Okay. So at this point, we've gathered the information that 2, -5 is in the relation, 1, 3 is not in the relation, and 2, 1 is in the relation. Okay. Is the relation a function? That's our next question to ourselves. Thoughts?
We have 50-50 chance, so I'm just going to say yes.
50-50 chance he's guessing yes.
There's no opposites in there.
Okay. So we have 50-50 chance here. We're guessing, some are guessing yes, some are guessing no. Okay.
I'm a gambler, man.
What if I say I have reason to know whether it's yes or no staring at me here?
I'd take your word for it.
I think yes, because there's 2 out of 3 that work.
It's not a function.
It's not a function because they don't.
It's not a function because wait. Yes, it is a function.
No, it's not a function.
Yes, it is.
No, it's not.
Yes, it is.
They can't.
Maybe it wasn't a function from the beginning
Wait,
because it has
I think
y
it's
squared.
Why do
Then
you
what?
speak at the speed of sound?
I want to know where Sophie was going before she got herself all yes, no, yes, no.
No,
Because
it is a
Like
function
an auctioneer.
because the 2 wide bodies are different. And just because the x values. Wait, no. Yeah.
Yeah.
What you
It's-
said.
It is a function.
Yeah.
so what do we know about this function?
No, it's not because the domains repeat.
What do we know about this function?
No, it's
I have
not.
come to the understanding that the equation.
No, that's where I was going, but I couldn't figure out whether range was x or range was y.
Okay, guys,
Sophie.
focus. If your conversation is off topic, drop it immediately and don't continue it again. Because I don't appreciate the yelling that's also going on this recording off topic. Is it a function based on the fact that we found that these 2 ordered pairs are in the relation? And this is where I thought Sophie was going until she got herself confused. But then Kylie caught on to what she was doing. What do we see here, guys? The x value 2 pairs with -5, and it pairs with 1. 2 is part of our domain. What's the rule about domain? It cannot repeat. Okay? So is this a function? This is not a function. And if you want to write an explanation for yourself, it's not a function because 1 value in the domain matched or paired with 2 values in the range. Or in other words, shorthand is domain repeats. If I graph these ordered pairs, right 2 down 5 and right 2 up 1, what kind of line would you draw? Or what would happen when you did your vertical line test? Yeah, it would touch twice, right? You'd have 2 dots there and it would touch twice. Okay. So yes, you know a little bit about functions. It's not a guessing game. Okay. Now, the other thing that was my clue, this is me as a teacher, less you as a student, but when I see a y squared in there, that's kind of my clue it's probably not going to be a function. Okay, y squared is going to create something that's probably not a function. Now, I won't 100% say because there's y squared it's not a function, but more than likely, because when we see like instead of y equals x squared, that's an upright parabola, right? When you see x equals y squared, my parabola goes sideways. Not a function. We'll learn about ellipses and hyperbolas that are not functions. Okay, that comes up in second semester when we talk about trig. Okay? Questions here? Okay. We're going to talk about relations defined parametrically. And I really don't think we've talked about parametric relations in Algebra 2. I think that is something that this is new to pre-calc. We talk about now. We might talk about the end of the year depending on our timing and how much we look at our vector chapter at the end. But relations defined parametrically, where both elements x and y of a relation are defined in terms of a parameter t. So basically you've got one equation that could be expressed as x and y, but instead it is expressed as two equations. For example, right here, this is an example of a relation defined parametrically. There's x that is defined in terms of t. So x is equivalent to t plus 1. There's y that is equivalent to t squared plus 2t. Now, it's an xy equation defined in a third parameter, that parameter being t. We can also put it together, though. Okay, and we will talk about that, part B here. So we're going to look at several things here in this example. But eventually, what we're going to look at is what is this? And it's actually an equation you're quite familiar with. Okay, it just doesn't look it. Okay. So, A asks us to find the points determined by t equals basically all the values from -3 to +3. In order to do that, let's see, where do I usually set this up? I usually set up a table over here, because when it's saying find all the points, what's going to happen? We're going to put our t value in the first equation and find n, x, and we're going to put that same t value in the second equation and find a y. Okay, so I'm going to go over here somewhere, and I'm going to have like 4 different columns here? I am. I'm going to have a t column. What are my input values for t? Well, the first one is what? -3. I'll list the others as I go. Now, then I'm going to have a column that uses to find x. How do we find x? X is what? T plus 1. So if x is t plus 1, what do we do when t equals -3? It's going to be -3 plus 1, which is what? -2. That's going to be my x. I'm going to have a y column. What do you think is going to be at the top of my y column? We're going to find y in this column. So t squared plus 2t. What am I putting in for t this time? Still -3. So -3 squared plus 2 times -3, which is what? 9 plus -6, which is 3. My third column is just putting it together as an answer. When t is -3, what ordered pair is represented? The ordered pair -2, 3. Are you okay with what I did there? Wait, do I want that line there? Maybe I don't want that. I kind of want that line there. Is it going to get messy? Mine's going to get messy.
I guess we'll find out.
Yeah. Mine's not necessarily as messy in my notes, but man, it's messy up here. Okay, what's my next t value? -2. So for this one, we're doing, for x, t plus 1, so -2 plus 1, which is -1. For y, -2 squared plus 2 times -2. Four plus -4,
0.
which is 0. What's my ordered pair? -1, 0. Keep going, yes? Next t value is -1. Now, do you feel like you need to keep showing your work in the x and y columns? And that's fine if you don't want to keep showing your work there. I wanted you to see where my magic number, they're not magic numbers, where they're coming from. But, now I'm going to put in Negative 1 plus 1, which is 0. Negative 1 squared plus 2 times negative 1 is
3.
I'm going negative 1.
Yeah, that's
I
what
don't
I.
know what I did.
Man, the math is bad out
I
there.
don't even know.
Okay, maybe we
I
should.
did my calculator wrong, that's why I got
I don't know. Maybe you should keep writing the work down if you skip that step.
Probably.
There's a lot of crazy answers out there. Negative 1 squared is 1. 2 times negative 1 is negative 2. So 1 minus 2, negative 1. Ordered pair is, unless I messed it up,
That
0,
makes me
negative
feel a
1.
lot better.
Okay. Putting in 0. 0 plus 1 is 1. Did I hear 0?
Yeah.
And then 0 squared plus 2 times 0 is going to be 0. So we have the ordered pair. 1, 0. Put in 1. 1 plus 1 is 2. 1 squared plus 2 times 1 is 3. 2, 3. Put in 2. 2 plus 1 is 3. 2 squared plus 2 times 2, 8. Ordered pair 3, 8. And put in 3. 3 plus 1 is 4. 3 squared plus 2 times 3. 15. So ordered pair of 4, comma, 15. And this is going to be helpful because if you've looked ahead, part C says to graph this. And this is going to help us graph it. Okay. So that was part A. Okay, obviously tweak that, set it up however you want on your own paper. I needed something that was kind of showing you where these values were coming from, right? Which is why I set up a big massive table. Maybe you don't like my big massive table. That's fine. You're allowed to not like the big massive table. Okay. Before we lose sight of these. Part B. I'm going to go over here for part B. I don't need quite as much distance up and down now. Find an algebraic relationship between x and y, and is y a function of x? Algebraic relationship. I'm looking for an equation. What is the equation that relates x and y? In other words, I want an equation that has x and y, but no t. That specifically uses these two equations. Now, pick one of these two equations, either the x equation or y equation. Solve it for t. Which one do you want to solve for t? Definitely. So I'm going to take x equals t plus 1. And if you want to write yourself a step, we are solving for t. So in order to solve for t, subtract 1, subtract 1. T is x minus 1, correct? Okay, guys. We picked one equation. Officially, there's not an equation you have to pick. In this case, there's an obvious equation to pick because the other one was not easily solvable for t. Now, once you have one of your equations solved for t, take it and plug it into the other one, right? So we're going to take this and plug t into the y equation. So my y equation was what? T squared, so that's going to be x minus 1 squared plus 2t, so plus 2 times x minus 1. We're not going to leave it like that because, again, part C wants me to graph. So I want something a little bit more familiar when I do the algebra. And the little note I'm going to make here is that we substitute t into, I'm going to say, other equation. Okay, just if you want to make yourself a note there somewhere about what are the steps we're taking, right? We picked an equation, we solved it for t, then we're going to take it and we're going to put it into the other equation. Now, if I do some cleanup, what do you guys know about x minus 1 quantity squared? Huh? More than x squared plus 1 because we need to FOIL. X minus 1 times x minus 1. Anytime you see a parentheses squared, you have to think FOIL. Now, I'm not saying you have to write it out as x minus 1 times x minus 1. You can FOIL that in your head. That's fine. I half expect that at this level. So when I FOIL, I'm going to have x squared minus 1x, and minus 1x is going to be minus 2x. Minus 1 times minus 1 is going to be plus 1. 2 times x minus 1, we're going to distribute. Becomes 2x minus 2. I have x squared minus 2x plus 2x cancel. Plus 1 minus 2 is minus 1. We went from a set of parametric equations where it's x equals and y equals, which makes this unrecognizable very easily. I have no idea what that equation is. To when we put it together without that third parameter of t, it's y equals x squared minus 1. What is y equals x squared minus 1? Parabola. Move down 1, yes? Okay. And so that's what we have there. Now, with that in mind, I almost forgot until I looked at my notes. Is this a function? Why? Okay, so 2 things. We can go back over here. Our x's were all unique, yes? And we didn't end up with, anything weird happening. We just talked about the shape of this graph, yes? Parabola, scoot it down 1. Does a parabola pass the vertical line test? Yes. So for those multiple reasons, yes, it is a function, however you want to write that. I wrote that weirdly. Function, comma, yes. Should have written that the other way. Yes, function, but,
Yes.
Take what you get here. Okay. Part C says to graph this. Now, I can graph this one of 2 ways, but here's the deal. We'll meet in the end. Because I see where this is going, I set it up so I don't have much down below my x-axis. I have more above my x-axis because that's where I'm going to need it. And by the way, I meant graph this by hand. Well, I was trying to why are people on their calculators? That's what I was processing. I'm like, oh, I said graph. They went for the calculator. Got it.
Absolutely.
Makes it easy.
Okay.
My graphic calculator.
And here's the deal. You can graph it on the calculator, I guess, but I don't want just a random sketch. I want to see where your points. So one thing, can we go back to these points over here that we got from part A? Yeah, we can. So left 2, up 3. We had -1, 0. Left 1, up or down 0. We had 0, -1. Left, right, 0, down 1. We had 1, 0. Right 1, up 0. We had 2, 3. Right 2, up 3. We have 3, 8, and 4, 15. Did you set yourself up to graph those? I definitely am not graphing 4, 15. I could possibly squeeze in 3, 8 on here if I wanted. But do you see what this graph is looking like?
Yeah.
Now, does this match with part B? A parabola scooted down 1. That means you take your vertex down 1, and what needs to be good knowledge in your heads is that what's a parabola do? From the vertex, the first set of dots go over 1, up 1. I taught this in Algebra 2. And then the second set of dots go over 2, up 4 from the vertex. Okay, I teach that in Algebra 2 that you need to know a basic parabola. It has that shape. And notice, over 1, up 1, over 2, up 4. So whether you use the information from part A or the information from part B to graph this, either way, you end up with the same graph, don't you? Okay. Or whether you use your graphing calculator, but I want you using your brain some too. Okay, questions there? Okay, you guys have what you need here? Inverse relations and functions. Again, something else we've talked about in the algebras. I say algebras because Algebra 1 and Algebra 2 we would have talked about this. But inverses. If an ordered pair, AB, is part of a relation, then what do we know about the inverse? Well, inverse is where you take your inputs and your outputs and you flip them. Okay, you switch them. So my x values and my y values switch. So if AB is part of a relation, then the ordered pair BA is in the inverse. Okay, so just knowing that you flip them. If the function has an inverse, because I can't always say that an inverse will exist, but if a function has an inverse, then it will pass the horizontal line test. Okay, that's new, but you know how the vertical line test for it works, right? Draw a vertical line. If it only touches the graph in one spot at a time, then it passes the vertical line test, and that says it is a function. Horizontal line test. Draw a horizontal line, and if it only touches the graph in one spot at a time, then that's saying that the inverse does exist. There is an inverse. Okay? So if a function has an inverse, it'll pass the horizontal line test. As it says, just like vertical except horizontal. What? Yeah. Okay. Functions that have inverses are called one-to-one. Okay. And when we get to the next page, we're going to look at them asking some questions. How do we know if a graph is a function? Passes what test? Well, if it's a function, it has to pass the vertical line test. How do we know it has an inverse? There, it has to pass the horizontal line test. So how are we going to know if a graph is one-to-one? Okay. If a graph is both a function and has an inverse, it's going to pass both horizontal and vertical line test. Okay? Key information there. Inverse notation. Inverse of a function. So a function is f of x. Inverse notation is, I read it as f inverse of x. It looks like a negative 1 exponent, doesn't it? Okay, so f negative 1 of x is in your inverse notation there. And to find an inverse function. This is where we talked about earlier that if AB is part of the initial relation, then BA is part of the inverse. Well, to find an inverse function, take x and y and switch them. Okay, so when we go to find inverses on the next page, we will switch x and y, and then notice it says solve for y. When we solve for y, that will be f inverse of x. Okay. Next page. I think you'll like these top few. There's 2 questions on each graph. Which of the following graphs are A, functions, so which are relations that are functions, and B, which are relations that have inverses? Okay? So, 2 questions here. A, relations that have functions. How am I going to know if it not has functions, are functions? How am I going to know if it is a function? If it is a function, it's going to pass the vertical line test. Okay, good. How am I going to know for part B questions if it has an inverse? If it passes the horizontal line test. Okay. What do you know about example A? Is it a, which one's A? Is it a function? Do I pass the vertical line test? I could draw over here, I could draw over here. So for part A, I'm going to say yes, as in yes, it is a function. Okay? And realize there's a vertical asymptote there, yes? And that's not going to affect whether or not it's a function. Okay? Part B. Does this relation have an inverse? So you're saying yes, as in what? It passes the horizontal line test. Okay? What's the special vocabulary for this one then? 1-to-1, yes? It's a function and it has an inverse. This graph is what we would call 1-to-1. Did they ask me that? No. Just, you know, trying to throw the vocabulary in there, right? Is something 1-to-1? This one is. It passes both. B. Is graph B a function? No? There's where I picked to draw my first line, and right there, failed the vertical line test. Question B, does this have an inverse? So it passes the horizontal line test? Okay. And here's the deal. You know, you draw most places, you're going to get 1. What's going on right here? There's asymptotes right there, okay? And that's a good way to put it. Kylie says probably an asymptote. Do we know that for sure? You know, I mean, we don't have the information, but we have the clues telling us. So, it's not a function, but it does have an inverse. Okay, C. Know what? Okay. It's not an oval, it's an ellipse.
It's an oval.
It's an ellipse. It's one of our conic sections we'll talk about in trig second semester. It's an ellipse.
They look scary.
You might have. And what I will say is it is in the Algebra 2 curriculum. Like when I look at my Algebra 2 book, parabolas, ellipses, and hyperbolas, and circles, or conic sections, are a chapter in the Algebra 2 book. However,
Circles.
what I will say is I never have time to do it in Algebra 2, and it's not a standard in Algebra 2. It's a trig standard.
We did it at like the very end because we did some trig stuff.
Okay, and that's the thing. I don't usually get to that in Algebra 2. So it could have happened in your Algebra 2 course. It just didn't happen in mine.
But we rushed through it.
Okay.
So we didn't.
Sophie, did you see anything? Okay. You're like, nope, this is not. Okay.
This is all.
This is like a teacher's spreadsheet.
Okay.
I don't know.
Well, I just know it wasn't, my Algebra 2, so. Okay, so an ellipse is not a function, and there's not an inverse. Okay, D. Is it a function?
Yes.
It's the vertical line. Oh.
That's
Okay.
That's a vertical line.
Did I miss the holding up the hand in the wrong direction?
Yeah.
Okay, now, and what are we going to assume is happening right here, guys? We're going to assume
Probably.
that those are likely asymptotes. Do we pass the vertical line test everywhere else?
Yes.
Yes. So, yes, it's a function. Do we have an inverse? No.
I never knew horizontal and vertical until someone told me the horizon
I
thing.
was just gonna tell you.
That's all right. I never knew horizontal and vertical
Nobody
either.
ever
so.
told me that until like 5th grade.
Horizon.
Sun. Something like that.
Okay.
I just remember it because I knew horizontal was sideways.
Yeah, so like the horizon, when you look out over the horizon,
That's the only way.
you're seeing like horizontal. I just know it now, but I was probably confused. I don't know, maybe when I was in
It
high
was
school.
just for like
still,
1 second. It's fine. I knew it
wasn't
all the other
correct with that.
times. They're just mean.
I know.
I was pretty close.
They would be the same way if I made the mistake.
It's a little funny.
So, okay, guys. The next part, example 4, is finding inverses. We did this in Algebra 2, guys. Okay, we did this. We found inverses in Algebra 2. So,
I did do these.
what do you know? We talked on the front page. What's true of an inverse?
Isn't it just like the reciprocal?
Not reciprocal. What did you say, Hannah? Flip, right? As in what flips? No. Remember, if AB is part of the relation, then BA is part of the inverse. So what we'll be doing is we'll be looking at taking our x's and our y's and interchanging them, and then solving for y. And I could start this one and get big in the middle of it, but that's the thing, I'm going to get caught in the middle of it. So we will start with this tomorrow. What do we know about f of x?
It's a thing.
That's y, yes?
Yes.
So when we talk about switching x and y,
Yeah, I remember now.
can I switch x and y now? Yeah, because f of x is the same as y. Homework. You, of course, are welcome to start homework. It will be due on Friday. So Friday. It's not due tomorrow, which is Thursday, so it's due Friday. That's what I'm trying to say.